Well, we're gradually moving into winter. It's getting closer and closer. It's hard to believe November is only about 4 weeks away. Halloween right around the corner. Well, it's a quiet night here in Texas, but some places around North America, out in the Pacific, they've definitely got some weather going on. Let's start out with the Atlantic. We'll switch over to that. Take a look at the products from NHC there. So we have Leslie still wandering around out there. This is currently right around Bermuda there. Winds are just below hurricane strength, and the pressure is 982 millibars, which is rather high. That's about what we see in a typical extratropical cyclone, so that's a fairly weak system there. We do have one system off the coast of North Nicaragua that has the potential to move into the Gulf, and we'll take a look at the prog there from NHC. And you can see that little area moving towards the Yucatan, and we're expecting the possibility of some formation in the Bay of Campeche in the southern Gulf of Mexico. However, out in the Pacific, we do have a major hurricane out in that region. Sergio, Category 4, 115-knot sustained wind, which is 130 miles an hour, and the pressure is 947. Now, that's certainly not near a typical storm like what you would see with Katrina or Andrew. This is more of a kind of a medium-grade hurricane that is going to be wandering out to the west, but we're expecting recurvature Sunday through Monday, and the remnants are expected to come towards California or Baja California around the second week of October. There's a look at Sergio there. Very well-developed system there. And you can see the incredible symmetry of the outflow region on the storm. This is mostly anticyclonic flow away from the storm in the upper parts of the cloud. Most of the heavier convection is close to the center, and the eye wall is going to be kind of right in there. But very wide eye there. And here's what it looks like on the Dvorak image. So we've got pretty much coverage all the way around of this lighter gray color, and we're starting to bring in the black colors. That's almost completely wrapped around the storm there. So these are colder cloud tops that are shown here. And typically with the strongest hurricanes, we see pretty much black all the way around, and some of the white also starting to enclose the eye there. Well, bringing that back in our region, let's see what's going on. SPC has a very quiet evening, except for the south plains of the Texas Panhandle there, around Lubbock and Plainview, La Mesa, and Childress. A few thunderstorms going on in that area. So what's causing those? Actually, let's take a closer look. We'll zoom in on their regional sector. I don't have GR level 2 up. Maybe I can bring up a product here. See if we can get a little bit of radar going. This has some links to College DuPage, and let me see if I can bring up one of these. Probably want to look at the Lubbock radar there. So, yeah, there we go. Doesn't look like supercell activity, nothing like that. This is kind of a merged area of multi-cell storms. This is pretty much from La Mesa up to whatever, that's south of Lubbock there, and a couple of cells further back to the west. Now let's look at the surface chart. Now your first inclination might be that the dry line is back, but that's not the case. If you look out in this area right here, San Angelo has south winds and 65-degree dew point. You go all the way out to Monahans, still out of the south 65 dew point, and we even have upper 50s out around Carlsbad and Roswell. So the dry line is actually way out in this area there. It is starting to make an appearance now that we're getting the prevailing westerly set back up. So there's the dry line out in that area. But the storms we're looking at are out in this region right there. So what's causing that? Turns out we've got a little bit of a warm front affecting that area. So let's do a very quick mesoanalysis. Front is very easy to find up in Oklahoma. You can see the winds converging near the Oklahoma City area. So there's the north winds impinging on south winds, and that places the front pretty much right in there. Now, going further down, we start to kind of lose the definition of the front. We do see some convergence up around Amarillo. However, the air mass south of that boundary is kind of cool. And we've got to be focusing on temperature, not wind convergence. So if we look strictly at temperature, well, we got 76 there at Clovis, 83 at Lubbock, 77 at Plainview, and that contrasts with these 88 to 90 degree temperatures to the south. So we're going to put that boundary probably something like that, and maybe I'll take a little bit of that wind convergence in that area around Hobbs and bring it kind of like that right there. So that appears to be where the front is, and that matches up pretty well where the thunderstorm activity is. So that's what's going on there. And what we're seeing here is the southeast winds bringing that moisture up and pretty much impinging right on that frontal boundary right there. Now, the better moisture is out to the east. We can see 70s dew points out in the Red River region, but the higher elevation out in this region here seems to be the dominant factor today, and maybe a little bit of weaker capping in that area. Okay, let's look at the national picture. Here's the surface map. And what we see here is this is that frontal boundary we were looking at earlier, and that's part of this larger scale system, and that comes all the way back into the Great Basin area where we have a well-developed baroclinic system in Idaho and Wyoming. And I would probably place that frontal boundary. Okay, got to play the cursor game, get the cursor back. There we go. I would actually place that frontal boundary maybe something like this. So from Salt Lake City out towards Elko and back towards Reno. And then maybe a warm front kind of like that right there. So that's what appears to be going on in that part of the country. Now, the frontal boundary that we have in the eastern U.S. that appears to be driven by this 1030 millibar high out across Lake Superior, and that's pushing a lot of cold air southward. You can see the temperatures there in Michigan in the 40s. It's impressive seeing those cold temperatures already. We've got 58 there at Detroit, 47 out around the Marquette area. I think that's Iron Mountain maybe, and 40s out around Minneapolis and La Crosse, and 53 at Chicago. So definitely a very cold day in that part of the country. And then down in the southeast U.S., rather quiet, just high pressure, a little bit of the Bermuda high still affecting that area, and out in the Gulf, easterly winds predominate, which is pretty typical for late fall. All right, let's head to the charts and see what's going on. Now, I know a lot of you are familiar with the SPC upper air charts, and that's what we are seeing right here. We don't really use these too often, and there's actually a reason for that. I mean, these charts look a little more technical. More people are familiar with that. And typically what we use is these charts. So the difference is this is more continental in scale. So we can see more of what's going on. We can see that Hudson Bay vortex up here and the very large aerial coverage, and we don't see that so much on this chart, which is pretty much the same thing. We only catch a little bit of that Hudson Bay vortex. So that's the reason we focus on this. However, I do like the SPC charts on storm days. We can get a little bit more into the mesoscale. This isn't really mesoscale data, but we might be able to pick out a little bit more detail on these charts. So we're going to be looking at these still until we have a storm day coming up. So it looks like we have kind of a split flow. Polar front jet down in California, Arizona. That could be a subtropical jet. And then another segment up to the north. Now, is this one a subtropical jet? We'll look at the 500 millibar chart, and it appears not. Still carrying about 50 to 60 knots there in Arizona, so that appears to be part of a frontal system in that area. And I'll just go down to 700 millibars, still kind of a fast flow in that region, so I do think that is a frontal system in that area. Here's a chart that we haven't seen in a while. This is the 500 millibar heights and vorticity. And give me just a moment here. I'm seeing some frame drops, and let me deal with this real quick. Just a moment.